Okay, so today's lesson is a review of right triangles and right triangle trig. So we'll start off by looking at a couple of definitions. So first there's the angle of elevation, which is an angle measured from the horizontal moving upward. And then next we'll have an angle of depression, which is the exact opposite. Also measured from the horizontal, but this time going downward. And so for both of these, we can draw a little diagram. So start with a horizontal line. You've got one there in your notes packet. And so then you'll draw the extra ray for the angle of elevation going up, or for the angle of depression, you'll start with your ray going downward. Okay, so then we'll get into some angles. And so far, we've drawn all of our angles in standard position. And I should have said this at the beginning, but you should be filling your notes in while I go through this video. You can pause the video at any time if you need extra time. All right, so for standard position, remember that we're measuring starting from the positive x-axis and rotating for positive, counterclockwise, and negative clockwise. And so an angle of 207 degrees is going to be somewhere in the third quadrant, since this is 180 and our unit circle angle 210 is about here. So we can rotate this guy around somewhere that would probably be about 210, so maybe just a little bit less. Okay, something like that. And then make sure to draw in that rotation showing what's happening. So this time we're drawing it from here and rotating around counterclockwise. And that shows our 207 degrees in standard position. So then what we're going to look at are a couple of other ways to measure or draw angles. Okay, next we'll look at bearing. And there's regular bearing, which we'll look at first, and then there's also more kind of detailed bearing that we'll get into. So first off, regular bearing, we're starting instead of on the positive x-axis, we're starting on the positive y-axis, which is due north. And this time we're going to rotate clockwise. So we're rotating the same amount, 207, so that rotation is going to be the same, except we're just rotating somewhere else. So clockwise is going to be going around this way. So we're going starting from due north, rotate around. That would be 180, so we need to go a little bit more. There's about 210, so there's about 207. And just like before, we'll draw in the rotation, showing where we started and where we ended up. So that's regular bearing. That always starts at due north, just like regular standard position always starts on the positive x-axis. So then we've got detailed bearing. And what detailed bearing does is it gives us a little bit more information. So it's going to tell us more than just the degree measure. And so we're not always starting at due north like regular bearing. So for detailed bearing, we're going to start at the first letter, wherever it is. And it's always north or south where we start. And so in this one, the first one, we're starting at due south because it says south 47 degrees east. Where the second one, we're starting at north because it says north 27 degrees west. So you'll always start north or south. Never start east or west. Then it gives an acute angle measure. So it's never going to go beyond 90. And it's going to tell us the direction to go towards. So this is saying south towards the east. So we're going to start here. And then the east is going this way. And we're going 47 degrees. So this will be about 45, so we want to go a little tiny bit more. So there's 47 degrees from south towards the east. So we'll show that rotation as well. Okay, so on the next one, try to draw in the north 27 degrees west based on what you think, based on what we did on this one. Pause the video if you need to, and I'll draw in the rotation as well. So I'm going to start at north, I'm going to go towards the west, still 27, so not very much. It's probably about 30 in there, 27 is pretty close. Okay, and I'll draw the rotation. So then we'll look at some examples, and these are directly taken from the book. So you can see on this one is problem 53, so this is on page 519, so it's going to be just like your homework. So take a minute to read through the problem, pause the video, read the problem, and then check back in. All right, so we've got a plateau that's 50 meters high, and the angle of elevation, remember that's from the horizontal up. So here's our horizontal, and then the angle of elevation in here is 20 degrees. And we're somewhere off in the distance. It's asking how far away are we from the top of the plateau. So what we really want to do is we want to have a math diagram, right? So this is our visual, but we want to draw a math diagram. And we're just taking the key information. So we've got a little right triangle here. And so if we're thinking about SOHCAHTOA with right triangles, then we've got from our angle 20 degrees, this side is opposite, this side is adjacent. And so if you're looking at opposite and adjacent, you're thinking about, in terms of SOHCAHTOA, you're looking at TOA. Okay, so what TOA says is tan of the angle is the opposite side over the adjacent side. So we're going to write that in a math sentence. Tan of 20 is going to be the opposite, 50 meters, over the adjacent x. Then we just need to solve this algebraically, so we're going to solve for x. So go ahead and solve for x. Use your calculator, pause the video if you need to, and I'll show you the answers. Finally, once you're done, make sure you're always writing your answers to word problems. They come in sentence form, so you need to write the answer in sentence form. And when I do that, I just take the words from the actual problem and rewrite them. So it's saying, how far are you from the base of the plateau? And I just rearrange the order of those words to write that as in sentence form instead of question form. How far are you? You are this far. So go ahead and read the next one. Again, pause the video if you need to, and then we'll draw a diagram. So on this one, we've got a building that creates a shadow. So the sun's got to be behind the building. If you drew yours exactly opposite, that's totally fine. So then the shadow extends out 50 feet. We know the building is 300 feet tall, and so we need to find this angle of elevation in here. So we'll draw that as a math diagram. And so again, we're looking at SOHCAHTOA. So try to think which part you're using, what sides you have. Okay, hopefully you said TOA again. So we have the opposite and the adjacent side to this angle x. Okay, so then we're going to set up our relationship. Tangent of the angle x is going to be the opposite side, 300 feet, over the adjacent side, 50 feet. So go ahead and calculate that value. Pause if necessary. So hopefully you got 80.54 degrees. And on both of these, I should have said on the last problem, if you're getting a different answer than I am, check your mode first. You should be in degrees for all of these. All right, so then just like the last one, write your answer as a sentence. The question is asking, what is the angle of elevation of the sun? The sun's angle of elevation is, and then 80.54 degrees. All right, so the next one is a little bit more complicated and will take a little bit longer to read. Definitely pause the video now so that you can read through the problem. Okay, so this problem involves a star, the Earth, and the Sun. And so you can see this diagram, and we've got our star out here and the Earth at one time, but remember the Earth is rotating around the Sun. Here's the Sun, so the Earth will be over here at some point. So it's on this orbit. So what we're trying to find out is how many miles the star is from the Earth. Well, we know how many light years it is. That was given in the problem. It's 4.22 light years from Earth, and it's also giving us that 1 light year is 5.9 trillion miles. So the first part of the question is just asking us to solve the dimensional analysis problem, which we practiced last semester with our angular velocity unit. So we'll start with our given information, 4.22 light years, and we're going to multiply by our ratio that really equals 1. So we're saying 1 light year is 5.9 trillion miles. Okay, since we want light years on the bottom, we're going to put that 1 there, and then the trillion miles that's equivalent, 5.9 trillion miles on top. Okay, so go ahead and calculate how many miles Proxima Centauri is from Earth. Okay, so we find out that Proxima Centauri is 24.898 trillion miles away from Earth. Okay, so let's say you didn't want to write 5.9 trillion miles. You could have calculated this in a very similar way by writing out all of the zeros for 5.9 trillion miles, and you'd still get the same equivalent final answer. It would just look different. So we can rewrite our trillion miles either with all of the zeros as just miles, or we can use the scientific notation. So that is up to you. Okay, the star is that many miles from Earth. So in the next part of the question, it's giving us the mean distance from the Earth to the Sun. So this little distance in here, and you can see on this new diagram, it's telling us that that is 93 million miles. And so it's asking what the parallax is. and the parallax is the angle. And so on this one, we're looking for, so if you're looking at the angle here, we see that we have the opposite side and the hypotenuse of the triangle. And so if you have opposite and hypotenuse, that's OH, so that tells us that we have the relationship so for SOHCAHTOA, so that's sine. So we're going to say sine of x is the opposite side, 93 million miles, over the hypotenuse, and whichever form you've written it in is fine. Okay, I just used all the zeros, and so then you can cross off a bunch of zeros. So then go ahead and calculate what the angle is. You are going to need inverses. Pause the video as necessary. Again, you can have your answer in different forms, and so go ahead and rewrite it in whichever form you like, but write your answer as a sentence. Okay, again, take a moment to read through the next question. Pause the video if you need to. Okay, so in this problem, we have an airplane, and they're giving us its direction. So it's telling us a lot of extra information. We don't need anything about this. Runway 4 right is just the name of the runway. And so what we know is that the airplane is going north 40 degrees east. So here's the airport. They're on this one runway that if you draw in your little compass, here's north and here's 40 degrees towards the east. So the airplane is traveling along this red line. And it flies for a half mile. Then the pilot says, I want to turn. And so it wants to turn at 90 degrees and head toward the southeast. So here's our 90 degrees. And so we can draw our direction. And you can see it's going towards the south. Here would be due south. Here's east. So towards the southeast, but at a 90-degree angle to its former path. And it wants to go for 1 mile. So we want this to be, this would probably be about a half mile. It's about equivalent to the previous ones. We want it to be twice as long. So you do need to make sure that your diagrams are accurate when you're drawing them. Okay, so now it's asking at what bearing should the control tower use to locate the aircraft. So here's the control tower, and so the control tower is looking out. The aircraft is over here, and it's saying, well, if I'm looking in that direction, this dashed line, at what angle am I looking? Okay. So we'll go ahead and add to our diagram. I'm going to label everything. All right, so here's our airplane. Here's the control tower. We're looking for the bearing. We're going to write the bearing in the same way that it was given to us in this detailed bearing. So we need the acute angle measure. We know the exterior angle, but what we don't know is we don't know the interior angle or even the bearing out here. But we can find the interior angle because we have a right triangle, and we know SOHCAHTOA. So according to this angle, we've got the opposite side and the adjacent, so we're doing TOA again. So we're going to say tangent of this angle is 1 mile over half mile, and we can find the angle measure of 63.43 degrees. We're going to hang on to that, so store it in your calculator. So what we really need is we need the exterior angle. So now we know 40, we know that, so all three of these angles should add to 180. So we're going to go ahead and subtract off 180 to find our bearing. So go ahead and calculate that. Okay, so you should have gotten an angle measure of 76.57 degrees, but we need to write it as a bearing measure. So we know the amount of rotation, but we need to say where we're starting and where we're heading. Remember, you're always starting from either north or south. In this case, we're starting from south. So you're never going to write your bearing as from east or west towards another direction. So our first letter is going to be south. And then we're going to look at what direction we're heading towards. We're going from south towards the east. So it's going to be south 76.57 east. So then write your answer as a sentence. The control tower should use a bearing of south 76.57 east to locate the aircraft.